intro.
Okay guys, so this time i-discuss naman natin yung tungkol sa 2.6.2 or the engine generated tractive effort. So the amount of tractive effort generated by the vehicle's engine is a function of a variety of drivetrain design factors. So for engine design, critical factors in determining output include the shape of the combustion chamber, the quantity of air drawn in the combustion chamber during the induction phase, and the type of fuel used and fuel intake design. Okay, so the two most commonly used measure of engine output are torque and power. So siguro familiar naman kayo sa ating mga terms na to since yung torque naman is na-discuss natin in mechanics of deformable bodies. So torque is the work generated by the engine or the twisting moment and is expressed in foot-pound or pound-feet. So power is the rate of engine work, so expressed in horsepower, and is related to the engine's torque by the following equation. So guys, if you want to know the engine generated horsepower or the HP sub E, so that is equals lang sa 2 pi multiplied by m sub E or the engine torque, which is in pound-feet, times n sub E or the engine speed in crankshaft revolution per seconds over 550. Okay, so next slide. So on this graph or dito sa table na to, so dyan sa figure na yan makikita nyo yung typical power torque curves for a gasoline powered automobile engine. So dito sa Y mo, that is 40 horsepower, and dito sa baba is the engine speed or the revolution per minute. And as you can see here, the power is directly proportional to sa torque. So habang tumataas yung torque mo, tumataas rin yung power na generate. And so as for the other table, so ito naman is in terms of power or kilowatts, or ito is nandun sa SI unit. Okay? So let's proceed with the next slide. Okay, so let's start with the problem. So sample number 4, this is for the topic of engine torque and power. So basahin natin yung problem. It is known that an experimental engine has a torque curve of the form m sub E is equals to a n sub E minus b n sub E squared, where me is the engine torque in feet-pound and n sub E is engine speed in revolutions per second. And a and b are unknown parameters. If the engine develops a maximum torque of 92 feet-pound at 3,200 revolution per minute, so what is the engine's maximum power? So at maximum torque, the n sub E is equals to 53.33 revolution per second. So kinuha lang natin yon by dividing the 3,200 revolution per minute by 60. And if you're going to take the derivative of that, so that will be d m sub E over d n sub E is equals to 0 or equals to a minus 2b n sub E. Okay? So by transposing the 2b n sub E on the other side, so we will have a value of a, which is equals to 2 times 53.33 times b, or that is 106.67 b. So we get a value of a in terms of b. Also at maximum torque, the equation will be m sub E is equals to a n sub E minus b n sub E squared. So by substituting the values there, so the equation will be 92. So yun nga given natin na torque is equals to 53.33 of A minus 53.33 squared ng B. And by using these two equations to solve for the two unknowns, we will find that B is equals to 0.032 and A is equals to 3.450. And using the equation 2.16, so yung dati natin ginamit, if i-check yung mga list of formulas natin, so ito yung equation niya, where yung HP sub E natin is equals to 2 pi times the quantity of ANE minus BNE squared. And again, that is just equals to sa maximum torque. So sinubstitute lang natin dun sa 2.16 and then to multiply that by n sub E over 550. Okay, so substitute nyo lang yung mga values there. So ang magiging sagot natin would be with respect to n sub e. And the first derivative of the power equation is used to solve for the engine speed at maximum power. So the equation will be equals to this equation. Ano? So substitute nyo lang siya. Ayan. So from where dHp sub e over dn sub e will be equals to 0, and that will be equals to 0.01142 times the quantity of 6.9 n sub e minus 0.096 n e squared. And then from there, we will find that n sub e is equal to 71.88 revolution per second. So the engine's maximum power is hp sub e is equals to 2 pi times the quantity of 3.45. Substitute nyo lang yung mga values na nakuha natin kanina. N sub e minus 0.032 n sub e squared times n sub e over 550. And then yung nakuha nating value ng n sub e, yung 71.88 revolution per second, substitute nyo lang ulit siya doon. From where, yung mapapalabas nating sagot for HP sub E or yung maximum engine power will be 67.87 horsepower. Okay, so this time under 2.6.2, so this is the engine generated tractive effort. Again, so given the output measures of a vehicle engine, focus can be directed toward the relationship between engine generated torque and the tractive effort ultimately delivered to the driving wheels. So, kuha lang ako dito ng mouse o ng laser pointer. Ayan. So, by definition, the overall gear reduction ratio refers to the relationship between the revolution of the engine's crankshaft and the revolution of the drive wheel. With this term defined, the engine-generated tractive effort reaching the drive wheels is given as using this equation. So we have F sub E, kung saan yung F sub E natin is the engine-generated tractive effort reaching the drive wheels, which is in the unit of pound. M sub E, so di ba yan yung engine torque natin? And E sub O, o yung epsilon sub O, that is the overall gear reduction ratio. So ito naman is given naman yan, ibibigay sa problem. Or may table na iproprovide sa inyo to find the overall gear reduction ratio. N sub D is the mechanical efficiency C of the drivetrain, and R will be the radius of the drive wheels in feet. It follows that the relationship between the vehicle speed and the engine speed is given using this equation. So kapag vehicle speed ang pinapahanap and kailangan mo maano yung mga given sa is yung relationship ng engine speed, so you will use this equation. So V, or the vehicle speed, is equals to 2 pi R times N sub E. Again, N sub E is the engine speed in crankshaft revolution per second. Quantity of 1 minus 1, so yung 1 minus I, so yung I po natin is the slippage of the drive axle. Generally taken as 2 to 5%. So yung value ng I natin ranges from 0.02 to 0.05 for passenger vehicle. And over epsilon sub O or E sub O. So to summarize the section, the available tractive effort F in equation 2.2 at any given speed is the lesser of the maximum tractive effort F max and the generated engine traffic effort F sub E. Okay, so as defined in the previous section, the available tractive effort can be used to determine a number of vehicle performance characteristics, including vehicle acceleration and top speed. So for determining vehicle acceleration, so under 2.7 na tayo guys, so equation 2.2 can be applied with an additional term to account for the inertia of the vehicle's rotating parts that must be overcome during acceleration. So this term is referred to as the mass factor, so designated by gamma sub m, and is introduced in equation 2.2 as F minus the delta R, or the summation of R, is equals to sigma m multiplied by m a. Ano ba tong symbol na to? Gamma or sigma. Anyway, so where the mass factor is approximated as, ayun nga, gamma, the mass factor equals to 1.04 plus 0.0025 of E sub O, or the epsilon sub O square. So when F net is greater than 0, the vehicle is traveling at a speed less than its maximum speed. So equation 2.19 can be written as in the differential form in this equation. So F net is equals to mass factor times m times dv over dt. Or if you're going to solve for the sigma, so that is equals to sigma m times m times dv over f net. So let's proceed with the next slide. Okay, so upon verification, so yung symbol nga na yun is siya ay yung symbol na gamma. Okay, so let's proceed. So, and because Fnet is itself a function of vehicle speed, so yung ating Fnet is equals to F, or the derivative of F with respect to V. Integration gives the time to accelerate as t is equals to gamma m times m, and then the derivative of dv over the function of v. So, yung limits niya is b1 up to b2. So, the b1 is the initial speed and the v2 is the final vehicle speed. Similarly, it can be shown that the distance to accelerate is given by this equation 2.22 as d sub a is equals to gamma m times m, and then the integral of v dv over f, or over function of v, and v1 of v2, yung limits niya. To solve for equation 2.21 and 2.22, numerical integration is necessary because the functional forms of these equations do not lend themselves to closed form solution. Such numerical integration is straightforward but requires a computer. Consequently, we do not provide an example of solving this equation. How sad. Okay, so let's now proceed with sample number 5. So under the topic of vehicle acceleration, so basahin natin yung problem. So a car is traveling at 10 miles per hour on a roadway covered with hard-packed snow. Coefficient of road adhesion is given as 0.2. So the car has a value of C sub D of 0.3. The A sub F is equals to 20 feet squared. And the weight of the car is given as 3,000 pounds. The wheelbase is 120 inches and the center of gravity is 20 inches above the roadway surface and 50 inches behind the front axle. The air density is 0.002045 slugs per cubic feet. The car's engine is producing a 92 foot-pound of torque and is in a gear that gives an overall gear reduction ratio of 4.5 to 1. The wheel radius is 14 inches and the mechanical efficiency of the drivetrain is 80%. If the driver needs to accelerate quickly to avoid an accident, what would the acceleration be if the car is, for letter A, if it's front-wheel drive, and B, if it's a rear-wheel drive? Okay. So the solution is as follows. So we begin by computing the resistance tractive effort generated by the engine and mass factor, because all of these factors will be the same for both front and rear-wheel drive. So the aerodynamic resistance, so from equation 2.3, is given by this equation. So again, RA is equals to rho over 2 times C sub D times A sub F multiplied by B squared. Okay? So given naman yung rho mo as 0.002045, so over 2 times C sub D, so 0.3 times A sub F na 20, and then given yung velocity mo as 20, so kinonvert niya lang to feet per second. Okay? So alam niyo naman kung paano mag-convert. So 5 to 80 divided by 3,600 and then squared. So the answer for RA is 1.32 pound. Next will be for the rolling resistance. So given in the equation 2.6 as R sub RL is equal to F sub RL times W. So given naman yung F sub RL mo as 0.01 and then yung W mo is equals to 1 plus 10 times 5 to 80 over 3,600 over 147 and then multiply by 3,000. Okay. So that is 32.99, and ito pala guys, yung W mo is yung 3,000. So itong F sub RL mo, ito, part pa siya ng equation na to, yung 0.01 times the quantity of blah. Okay, so for the engine generated tractive effort, so given on equation 2.17, so we have an equation of F sub E is equals to M sub E times epsilon sub O times N sub D over R, or that will be 95 times 4.5 times 0.8 divided by 14 over 12. So the answer for F sub E, or the engine generated tractive effort, is 293.14 pound. And for the mass factor, so from equation 2.20, so that is gamma m is equals to 1.04 plus 0.0025 times epsilon sub O squared, or 1.04 plus 0.0025 times 4.5 squared, or the answer is 1.091, and then upon getting the mass factor, So recall that to determine the acceleration, we need the resistance already computed earlier and the available tractive effort F, which is the lesser of F sub E or F sub max. For the case of the front-wheel drive car, so equation 2.15 can be applied to determine the F max. So ito yung equation na gagamitin natin. So F max is equals to mu, or the coefficient of friction, times W, times the quantity of I sub R plus F sub RL times H over L, and then 1 plus mu H over L, or simply substitute all the given in the problem. So 0.2 times 3000 times 70 plus 0.011 times 20 over 120 plus over 1 plus 0.2 times 20 over 120. Or the answer for a front-wheel drive, so kung ano yung hinahanap dito, so that is if the driver needs to accelerate quickly, so what would the acceleration of the car is if it's in front-wheel drive. So ito yung sagot natin for letter A. Okay, so next, so that's for a front-wheel drive car, so 293.14, the lesser of 293.14 and 339.77. And the acceleration is given from equation 2.19 as follows. So F minus the summation of R, or delta R, is equals to gamma M times MA. So in order to solve for A, ito nga yung hinahanap sa problem, so that is acceleration is equals to F minus summation of R, or the delta R over gamma M times M. Or just substitute the value, 293.14 minus 34.31 over 1.091 times 3000 over 32.2. So the answer for letter A is 2.546 feet per second squared. And for the case of the rear-wheel drive car na bubulol, so equation 2.14 can be applied to determine the F max. So substitute mo lang value to find the F max considering a rear-wheel drive. So 0.2 times 3000 times 50 minus 0.011 times 20 over 120 over 1 minus 0.2 times 20 over 120. So the answer is 257.48. And that's for a rear-wheel drive car, so 257.48. So if the lesser of 293.14 and 257.48, and the acceleration is from equation 2.19. So I consider natin yung lesser, so that is yung 257.48. So ganun lang din, yung kagaya nung anina. So F minus delta R over gamma M times M. So 257.48 minus 34.31 over 1.091 times 3000 over 32.2. So the answer is 2.196 feet per second squared. So as you can see, mas mabilis yung acceleration natin do sa front-wheel drive compare kay rear-wheel drive. Ano? Meron pa bang rear-wheel drive? Okay, so example 6. So that is for engine torque and vehicle acceleration. So the front-wheel drive car is in gear with a gear reduction ratio 5:1 and is traveling at 25 miles per hour. The engine torque of the car is given by the equation M sub E is equals to 10 times N sub E minus 0.06 N sub E squared. The car has a frontal area of 20 feet squared, from where yung C sub D niya has a value of 0.3, and is traveling at sea level 59 degrees Fahrenheit on a level road. The wheelbase is 120 inches and the center of gravity is 40 inches behind the front axle and 30 inches above the road surface, and the car weighs 2,800 pounds. If the car is on a road that is wet with poor pavement, what is the maximum acceleration from 25 miles per hour? Driveline efficiency is 90% and the slippage of the drive axle is 2%. Wheel radius is 15 inches. So ang hinahanap is the maximum acceleration. Okay, so solution to begin, the engine speed must be computed so that the torque equation provided in the problem state that can be applied to determine the engine generated tractive effort. This is done by applying 2.18 equation with I, which is equal to 0.02. The E sub O, or the epsilon sub O, is 8. R is 15 over 12 feet, and the velocity is 20 miles per hour. Okay, so V is equal to 2 pi R N sub E, quantity of 1 minus I over E sub O, or that is equals to 20 times 5 to 80, so divided by 3,600, and that is equals to 2 times 3.141 times 15 over 12 times N sub E, quantity of 1 minus 0.02 over 8. So the value of your N sub E is given as 38.22 revolution per second. So, sinolve niya lang in terms of N sub E. Ito yung lumabas na sagot, 38.22. And then substituting the engine speed into the torque equation provided in the problem statement gives M sub E, or 10 times 38.22 minus 0.06 times 38.22 squared. Or the answer for M sub E is 294.55 feet-pound. So ito yung torque. So the engine generated tractive effort. So from equation 2.17 with N sub D as 0.9. So F sub E can be computed as M sub E multiplied by epsilon sub O and N sub D over R, or 294.55 times 8 times 0.9 over 15 over 12. So the answer with that is equals to 1696 or 1696.63 pound. Okay, so as an example, in 2.5, the available tractive effort for maximum acceleration F is the lesser of F sub E or F sub max. F sub max for a front load or the front wheel drive car is computed using equation 2.15 with the given values of L sub R na 80 inches, H na 30 inches, L na 120 inches, the W na 2,800 pound, and the mu, which is equal to 0.6, kung saan ito is nakuha doon sa table 2.4. So under the category na poor and wet pavement. And F sub RL from equation 2.5, we find that yung F sub RL mo will be equal to 0.01 times the quantity of 1 plus V over 147. Or that is equals to 0.01 times 1 plus 25 times 5,280 over 3,600 over 147. Or F sub RL mo is 0.0125. Application of 2.15 yields that F sub max is equals to mu times W times I sub R plus F sub RL times H over L plus 1 plus mu sub H over L. Or substitute mo lang yung mga value, or that will be 0.6 times 2,800 times 80 plus 0.0125 times 30 over 120, and then over 1 plus 0.6 times 30 over 120. So the answer for F max is 978.48 pound. Thus, 978.48 is the lesser of 978.48 and 1696.63. With this, the acceleration is determined by applying the equation 2.19. So for input into 2.19, the rolling resistance from equation 2.6 is R sub RL is equal to F sub RL times W. So yung R sub RL mo is 0.0125 times 28 or equals to 35 pound. The aerodynamic resistance we draw as 0.002378 slug per cubic feet as per the table 2.1. So CD 0.3 AF as 20 feet squared, and the velocity is 25 mile per hour. So R sub A is equal to rho over 2 times C sub D times A sub F times V squared. Or that is 0.002378 over 2 times 0.3 times 20 times 25 times 5,280 over 3,600 squared. Or R sub A is 9.63 pound. Thus, the mass factor is given by the equation 2.20, or that is gamma m is equal to 1.04 plus 0.025 times 8 squared, or that is 1.2. Thus, application of equation 2.19 gives the maximum acceleration as F minus the delta R is equal to gamma m times m sub A. Or if you're going to solve for A, so cross multiplication mo lang, so F minus delta R over gamma m times m, or 978.48 minus 35 minus 9.63 over 1.2 times 3,000 over 32.2. So the answer will be 8.95 feet per second squared. Okay, so for fuel efficiency, so the engine designs that increase the quantity of air entering the combustion chamber improves the fuel delivery of the combustion chamber and decrease the internal engine friction, which leads to the improved fuel efficiency. Improvements in other mechanical components such as decreasing slippage and improving the mechanical efficiency of the transmission and drive shaft also increase the overall fuel efficiency. So in terms of resistance reducing options, decreasing overall vehicle weight, yung weight ng car mo, will lower grade and rolling resistance, thus reducing fuel consumption, all other factors held constant. Similarly, aerodynamic improvements such as a lower drag coefficient and C sub D and a reduced frontal area A sub F can produce significant fuel savings. Finally, improving tires designs with lower rolling resistance can improve overall fuel efficiency also.